Guys, welcome to the second day of looking at 10.1. We're talking about using the disk method to find the volume. On the first day of 10.1, we looked at horizontal rotations. So when we either rotated it about the x-axis, or sometimes we might rotate it about a different horizontal line, like y equals 1, or y equals 4, or y equals -2. But all of those rotations were horizontal. And remember that all of our pieces of our function, all of our lower and upper limits, and our everything that we had was in terms of x. So the integral was being taken with respect to x. What we're going to look at today is we're going to look at rotating vertically. So if we have a vertical rotation, that means we're either going to rotate it around about the y-axis or a different vertical line like x equals 2 or x equals -1. Okay, so just to get a visual, if we took this function right here and we rotated it about the y-axis, then what we would end up having would be something like this, and it would have a rounded shape. So it kind of looked like if you took a piece of Play-Doh that was a ball and you started smushing it between your hands. That's kind of what this would look like. Okay, so that would be us finding the volume of this. So there's it's the same idea, except there's going to be a little bit of extra work that we have to do now, because when we are going to find the volume and we're rotating it vertically now, vertical rotations, the limits and the functions have to be in terms of y and with respect to y. So that means now everything has to be in terms of y. So the way that we could write this would be pi times the integral, and I'm going to use a c and a d now, just so we know that these are different than a and b. A and b were in terms of x, c and d are in terms of y. And this time it's going to be the right function minus the left function squared with respect to y, so dy. So it's essentially the same thing, except because these functions are going to be in terms of y, we have to use a right function and a left function. Okay. As I work through this lesson, you're going to hear me also refer to right and left as outer function and inner function. That's really going to help us when we look at the next lessons. So I'm going to start using that terminology. So you might hear me call the right function the outer function, and the left function being the inner function, or the inside and the outside function. Sometimes it just looks a little bit different, and sometimes hearing the word outside and inside helps get a better idea of what we're talking about here. Okay, it's the same equation, just using right and left and making sure everything's in terms of y. Okay, so let's look at the example 1 here. So we'll start with this first one. It says, example 1, set up and evaluate the integral that gives the volume of the solid formed by revolving the described region about the y-axis. So here's our first clue right here, that we're going to revolve it around the y-axis. So that means it's going to be a vertical rotation. So this should tell us automatically that we are going to be using this function right here, right minus left squared dy. Okay, so let's look at our equations. The first thing that I strongly suggest that you do on every single one of these volume problems is give yourself a sketch. You need to be able to visualize what object we have here and what it would look like and how we're rotating it. So the first thing that I'm going to do is we're going to draw a graph. So my x and y axes. Okay. For those of you who don't know, okay, we can put y equals x to the 2/3 right into our graphing calculator. You can use Desmos.com, whichever way is the easiest for you. So when we do that, we're going to get a 1, a 1, -1, -1. So what it looks like, here, I'll just show you just so you guys can see. Here's, I've got Desmos up here, so all we have to do is type y equals. You don't even necessarily have to, but I'm going to for the sake of this stuff. X, and then remember, do Shift 6 to get that little rooftop or caret, and then you're going to type 2/3, so 2 divided by 3, and you're going to see that the graph you get is kind of that funky looking V, okay? It's got that cusp on it. So now that we've kind of got that visual, you can see here that this point is at 1, 1, this point is at -1, 1, so that's all the part that I'm going to put on my little graph here. So it's going to put a 1, 1, 0, 0, -1, 1, and this kind of has like this awkward backwards curve to it. Okay, now I'm going to take a couple other colors here. Let me use pink. So I've got an x equals 0, so where my x value, so x's are this way, so where x is 0 is here, so that would be this line here. Okay, where y equals 1, that is going to be, well, here's my y value, so y is 1 is here, so that's all of these values here. Okay, but then if you look here, it said that we're only going to talk about quadrant 1. So that means that I'm only concerned with this section right here. And what we're going to do is, this one said we're going to rotate it about the y-axis. So that means we're going to rotate it about this vertical axis. And what's kind of nice, because I already drew this side, you can kind of already get a visual. So this is what we're going to have, except these are going to be like a rounded shape, each one of these. We get a bunch of different cross sections, so it's going to kind of give us like a interesting cone shape here. Okay, so we've got our picture, we got our image, we see what it's going to look like, three-dimensional. So this is a completely solid object. We're revolving it around one whole side of the function itself. Okay, so what we need to do now is we need to figure out what is the right function and what is the left function. So if we're talking about here is where we're rotating it, the function farthest to the right from it is going to be the function itself, x to the 2/3, and then the function closest to it is going to be the axis itself, which we said was the x value of 0. Okay, so we're using this pink line where x is 0, and we're using this outside one where y is x to the 2/3. Now, there's an issue with this, because remember we said when we're using this, because it's a vertical rotation, everything we plug in here has to have y's in it. Well, x equals 0, that's already in terms of y because it's solved for x. This one right here, unfortunately, is in terms of x because it's solved for y. So what we need to do, and I'm going to do it over here on the side, we need to take y equals x to the 2/3, and we need to solve for x. We need it in terms of y, so we need to solve it for x. Okay, well, how do we solve this for x? What I would do is I would rewrite this as y equals, remember our little rule, the flower is the power, the root is the root, so this is the cube root of x squared. This kind of gives me a better idea of what I really need to be doing. So to get rid of a cube root, we cube both sides. So now I have y cubed equals x squared. Okay, to get rid of a square root, to get rid of a square, we square root both sides. Okay, so now I have an x equals, and I'm going to rewrite this one as a power. So the flower is the power, and this is a square root, the square root. So if you'll notice that basically this fraction just became the reciprocal. Okay, so now our equation is in terms of y. So this is what we're going to need, and this is what we're going to need. We said this one was going to be the right function, or the outside function, and this one is the left function, or the inside function. Now, inside just means it's the closest to where we're revolving it. Outside means it's the farthest from where we're revolving it. Okay, so what that function is saying is it's the distance from the place of rotation to this function. Well, that radius, that distance, is always going to be whatever the value of the function is there. And then the distance to the actual line we're rotating it about to itself should be whatever this number is. Okay, so now we're just going to plug it in. So our volume is going to be pi times, now here's the next thing, these two numbers have to be in terms of y. That means I need my lowest y value that we're using to the highest y value. Well, the lowest y value we're using is 0, and the highest y value we're using here is at 1. Okay, then we said our outside function is y to the 3/2, and our inside function is 0, and we're squaring that whole thing, and this is in terms of y. Now, if you're plugging this into your TI-84, then remember you're just going to use an x in both of these places. If you're going to use Desmos, you can either use an x there, or you can actually use a y. Either way, let me jump back to Desmos, and I'll show you what this looks like when we type it in. So just as a reminder, we're going to type pi, and it'll give us pi. Then we're going to type in int, and it's automatically going to give us our integral. Our lower limit was 0, our upper limit was 1. Then our integral, remember, use 2 sets of parentheses here. Okay, then we're going to type in, I'm just going to do the y's on here so y'all see. So y, then shift 6 to get our exponent. 3 divided by 2. Okay, I'm going to close that set of parentheses. Then we're going to subtract our second equation, which was 0. Then I'm going to close that big set of parentheses. I'm going to square this whole thing. And then I'm going to make sure I put dy because I use the y. And we're going to see that the answer we get is 0.78539. Please go ahead and round to 3 decimal places here. Okay, so we've got that our volume is approximately 0.785. Okay? Alright, so I know that took me a little bit longer, but I wanted to make sure I took my time going through it. I'm going to change videos and do the second example, and then maybe even work out one of them from the practice, just so I can go a little bit quicker. This part is the part that's going to trip you guys up, making sure that it's always in terms of y when you plug it in to the equation when it's a vertical rotation. Okay, so I'll see you on the next video.